A receptor. Something monitoring conditions. As you sit here right now, what type of conditions does your body need to control for you? Breathing? Light? Temperature? Got some pressure down here. Y'all sitting down, I'm not. I was trying to do the pressure sitting in the chair. Are my muscles going to behave when I get up to go run out to the classroom when Dr. Young says, okay, bye, see y'all tomorrow? My heartbeat? What else? Everything. Stuff that you're not thinking about, right? Like my hearing, my salivation, my smell, my sight, pressure on my butt from the chair, muscles that need to get ready when I have to get up, temperature, blood pressure, chemical composition. I mean, the list, that's what y'all are here for, okay? There are receptors everywhere receiving this information. If you had to be aware of all of this information 24/7, you'd go insane. But because the body does this for you, hey, you get to be here in my class. All right? Now, information that gets picked up by all of these receptors, it goes to a control center, that primitive area of the brain. And that primitive area of the brain is going to have control centers for all of this. Temperature, blood pressure, chemicals, muscle movement, breathing, heart rate, you name it, okay? It's got controls for it. So when information goes in to the control center is going to basically say, okay, well, here's what we got to do, and it will send an effect. Therefore, sending a response to the effector. Now, what does that mean? Now, that's going to be a little more than just our primitive region of the brain. That's going to pull in some of the higher order skills and other parts of the brain. But let's say that I were to change the light level in here. Right now, kind of low, okay, because it kind of makes the screen easier to see. But if I were to go flip the other switch, bring more light in here, what's going to be one of the things you do? Okay, you're going to be like, ooh. Okay? That's controlled by the primitive areas. But there was a receptor, there was a control center, there was an effect. The effector was what? I don't expect y'all to know this, but if you do, oh man, you get major kudos if you know this. Yes, it's going to be controlling the pupils. Do you know what controls? The what? Well, what's going to control the size of that pupil that's going to react. I recorded it. You're good, okay? There are these tiny little muscles, okay, that are in the eye attached to the pupil, okay? Pupillary constrictors and dilators, all right, that control that. They're totally controlled by the autonomic nervous system. It is the coolest thing ever, okay? And it's the reason that they'll either open up or shut or constrict. It is so cool. But those would be the effector. Does that make sense? The receptor was the amount of light. Control center, areas of the brain. Effector, those tiny muscles around the pupil. Is that not the coolest? Trust me, that ain't the coolest. But we're going to go with that for right now. Okay? So, whenever there's a stimulus, that stimulus, like for example, changing the light level, okay? The stimulus was something that made the set point go off balance. The body wants to bring it back, okay? And therefore, whatever response is given to the effector, hopefully, will bring the body back to homeostasis. All right? So, for example, if, I don't know, turn the temperature in here up to 100, we would have these thermoreceptors that would send information to that area of the brain. The effector would be the capillaries in the skin that are going to make you sweat. Kind of cool. So, for the most part, the way that the body is going to maintain homeostasis, we're going to use negative feedback. Negative feedback, something takes it away from set point. Information goes to the brain, for the most part, you know, my primitive area of the brain. Response is sent to an effector. They happen to be showing the heart here, okay? They're given the example of blood pressure. They tell us the norm for blood pressure should be what? And for you, probably 110 over 70 is where they want it to be. Because the younger you are, the lower they want the numbers to be. All right? If you get to be my age, they'll probably accept like 130, 140 over 90. Okay? Because things don't work the same the older you get. Trust me on that. Okay? So, blood pressure, what they're kind of showing us is we have receptors to monitor the pressure as the heart ejects blood into the aorta, okay? And that pressure is monitored. If it's too high or too low, information goes to the primitive areas of the brain that are monitoring blood pressure, and it will send effects to the heart muscle to either increase or decrease the heartbeat so that we can bring blood pressure back to norm, which we'll learn more about in part 2. But negative feedback, bring it back to the set point and the acceptable limits. Now, depending on what that is, okay, those acceptable limits can be a little wider, or those acceptable limits are very little. For example, the pH of the blood, the body will not allow the pH of the blood to change very much. Because the pH of the blood changes too much, you start messing with a lot of stuff in the body. Now, does the body have the ability to change under certain conditions and come back to normal and still have everything be okay? Of course it does, okay? How many of you in here exercise? I didn't make a New Year's resolution, okay? Because I don't believe in it, all right? But I was like, okay, you know, I need to get back into going to the gym.